Hey guys, this is Cody.
And this is Clara.
Today we are going to be showing you how to do the AP Calculus AB 2015 free response question number 3. I will be writing in the blue Expo marker.
And I will be writing in the red Expo marker.
We've gotten a few fellow AP Calculus classmates to work out our problem, and from their mistakes and struggles, we have come up with some tricks to help you.
So let's jump right in. Joanna jogs along a straight path from 0 to 40. Joanna's velocity is given by a differentiable function v. Selected values of vt, where t is measured in minutes and vt is measured in meters per minute, are given in the table above.
Okay, so from the units in the data table, we know that Joanna is traveling a distance for 40 minutes. The vt, which is the velocity that Joanna is jogging, is the speed that she's traveling in a given direction. From the data table, we can now conclude that Joanna was traveling in a positive direction, which is to the right from 0 to 20 minutes, and at 24 minutes, she's headed in an opposite direction. Then, at 40 minutes, Joanna is traveling again to the right.
Thanks for the analysis, Cody. For the explanation he gave us, it will be easier to comprehend the question. Now let's get started on part A. So it may be a little confusing to know what the examiners are wanting you to do because there is no data for 16 in the data table. But never fear, we can figure it out. We are going to show you 2 ways to approach the problem.
I will be showing you the algebraic approach for part A. We will need to solve for the slope of the graph and between the 2 points given to us on the data table that are closest to 16. Because we do not have enough information specifically for the point 16, we are going to have to use these points, 12 and 20, to give us the best estimate we can get with the information we have. If you don't already know, the slope formula is m equals y2 minus y1 over x2 minus x1. With this, we will need to plug in the correct values into the equation. The higher value, 20, will be x2, and its y value will be y2. And therefore, 12 will act as x1, and its y value will be the y. From here, all you need to do is just plug in chug. The final answer that you should have gotten is 5 meters per minute squared.
Great job, Cody. Now I will be showing you how to do it graphically. So we will still be using the same points, 20 and 12. We will begin by plotting each point on the graph, then drawing a straight line between the 2. Then we will solve for the slope of the line using rise over run and get the same answer, which is 5 meters per minute squared.
That's how you do part A. Easy, right? Okay, now let's begin part B. Using correct units, explain the meaning of the definite integral and the content of the problem. Approximate the value of the integral using a right random sum with the 4 subintervals indicated above. Okay, for this part, you will need to know what a definite integral is and how to apply it to any given problem. The definition of an integral is the total area between the curve and the x-axis under a curve. With this in mind, we can now apply it to the problem and can conclude that in this situation, the area underneath the curve would be the distance that Joanna is traveling. Remember, the integral has an absolute value around the velocity. Thus, the distance traveled will always be positive. For example, in a car, when you are driving down the road, the speedometer is positive, and when you put your car in reverse, the speedometer continues to be positive. This is because when you are traveling in a car, reverse or drive, you will always be traveling a distance. With this, you can make the assumption that velocity needs to have an absolute value because you want to calculate the total distance.
Then you just have to do the right random sum. Your final answer should be 7,600 meters. Now we will begin solving for part C. We are trying to find Bob's acceleration. We are given Bob's velocity as an equation, and acceleration is equal to the derivative of velocity. So deriving the given velocity will give us the equation for acceleration. Now we just need to plug in phi for t and solve. The answer you should get is 15 meters per minute squared. A derivative is equal to delta v over delta t, and the delta v is meters per minute, and the delta t is minutes. So therefore, the units of the answer are meters per minute squared.
Awesome. Now we only have one more part to look at. Based on the model B from part C, finds Bob's average velocity during the interval 0 to 10. Okay, so this question may be a little tricky when you're trying to comprehend what they're asking for. But once you know where to start, it's pretty simple. In the problem, it states that they are looking for the average value of the velocity. Therefore, we are going to need to use the average value of a function formula. When finding an average, you find the sum and then divide it by the interval. The equation shows just that. Another way of writing it is 1 over b minus a times the integral. Another way of writing it would be the integral divided by b minus a. It is over the interval 0 to 10, so the higher number, 10, will represent b, and the lower number, 0, will represent a. Plug in these values and then plug it into the velocity equation.
Without a calculator, this seems pretty intimidating, but we can do it no problem. We will just solve the integral of the velocity equation. The final answer should be 350 meters per minute.
That wraps it up.
Thank you for joining us on this tutorial.
We hope that this helped you and hopefully you'll do great on the exam.
They most definitely will. Bye.
Bye.